are, so we are working on which one? 14 point, oops, sorry. Okay, on the page, which page is that? On the page 368, right? In the text, okay? All right. And we just read this question. Everybody clear? We read this question, okay? And so we have a normal, or rather normally distributed population, right? That's what they told us, right? Then the population is standard deviation is, what did they give it to us? 0.2 units, right? Okay. And the sample readings are 5.30. Yeah, thank you, Carlson, very kind of you. Then next one. 4.88 what? 88. Okay, great. 5.1. 4.73. Thank you. 5.15. 5.15. 4.75. Thank you so much. Okay, everybody good? Okay, that's what we got, right? Okay, so, and we have to do what? To construct a 90%, right? Confidence interval for the population mean, right? Good. So let's work on it, okay? So now first thing we will do is this, that let's just write, who is our estimate? Our estimate is the sample mean, right? Everybody clear? Okay. So how do I get the sample mean here? Anybody? Somebody, anybody? Add them up and then do what? By the number of, okay, right, 4.88, then plus what? 5.1, then 4.73. Very nice of you. Then very good, thanks. And then we divide it by 6, and there's so many people watching me do this, so if I made any typo or anything, it will be caught, right? So is that good? Okay, oops, sorry about that. Okay, so here we go. Let's bring that in our notes, okay? All right, so here the sample mean is what? Come on, why are you not coming in? Because, okay, here you go. Good, great. Okay, so this is the sample mean. Now we need what? We need the margin of error, right? Everybody clear? Okay. All right. So now for the margin of error, what do we know about the margin of error? It is, where are you? Right here, Z star, right? Where Z star depends on what? Z star depends on the confidence level, right? Times what? Sigma. Who is sigma? Sigma is the of the population, right? Everybody clear? Okay. And n is what? The sample size, right? So here we go. So we have this guy right here for our margin of error, okay? So in this case, I know that n is what? N is, help? 6, yeah, right, the sample size, you're right. Okay, how much is sigma? Sigma is 0.2, right? Units, of course. We are not writing the units here of that because sounded a little complicated, but when we are saying units, we know that we are sensitive to what we are working with, right? Now, this quantity Z star, okay, that does what? Depends on the confidence level, right? On the confidence level. Everybody clear? So, and there are two ways of doing that. One is you have table in the book, and the table does what? I just did this. I got a, like this, I created the same table in Excel. Let me enlarge the letters because, I'll enlarge the letters because it's almost the same table that you have in the back of the book. So what do? We look at the 90% confidence here, right? Carlson awake, right? Okay, 90%, and then when you go down to the bottom in this row, what do you see? What's the value for Z star here? 1.645, right? Erica, is that clear? Okay, so that's 1.645. So that's one way of doing that. That is from the table for 90% confidence, Z star is what? 1.645. Okay, everybody clear? Or you could do this, that if I am looking for a 90% confidence interval, all right, then what I am asking for? I'm looking for this. That is, I'm looking at Z star. Let's get our Z star here in the picture. Okay, so here I'm just getting Z star for you. Okay, where are you? Right here. Okay, just will be a second. Okay, so there you go. Okay, so here we are. Okay, one moment please. Okay. Yeah, I should have made it here for you in advance, but anyways. Okay, so there you are. So now if you are, say, if I don't have a table, no problem, I have my calculator, right? So since I have my calculator, I can use my calculator to get that Z star here directly. How? I know this, that here I'm sort of cheating a little bit because I already know what that is, but anyways. And I don't know what got screwed up, messed up here, I'm sorry. Okay. Okay. So this area in the middle is what? This area in the middle is, help, here what that is? Yeah, which level confidence interval we want here? 90%. So this area is 90%. Everybody clear? So this is 90%. So the tails combined are how many? How much? 10%. Everybody good? Right? Because this is 90%, the whole thing is 100%, right? Okay. So the tail on the left is what? Is 5%. So our Z star that we are trying to find, that's what? That's 95th percentile of the standard normal. Everybody clear? Okay. So how do we get the percentiles in our calculator? I'll just bring here. Yeah, where do I go? Somebody, anybody, quickly? Help. Second. All right, so we go to distribution, right? And which feature is going to help me?
The third one, inverse normal.
Okay, inverse normal. Very good. Thanks, Francois. All right, and we want which one? 95th percentile. Now, since we are in standard normal, we don't have to put the parameters because it takes them by default. And what do we get here then? We get 1.645 approximately, the same value that we had before, right? Everybody clear?
What are the default parameters?
0 and 1 because standard normal distribution. Okay, Brogan? Thank you. Everybody good? So now we are set to compute the margin of error, right? Everybody clear? Okay, so let's compute the margin of error. How would we do that? Z star is right here 1.645, right? And what will we multiply it with? 0.2, right? Okay, 0.2 is the value, right here. Divided by what? Square root of 6. And that comes out to be what? Etc. etc. Right? So do we have it right? I hope so. Okay, good. And what was the mean? Mean is 4.98, right? So, sorry about that. A 90% confidence interval for the mean is what? Is 4 point, let me approximate, and minus, what was the margin of error? 0. Yeah, 134, and I think it will be fair. Let's 1343 is good. And here what we have? 4.9883. Yeah, let's try to be reasonably precise, right? And then who is this? Right. Could somebody give me those values, or I have my calculator, I can always obtain it for myself. Somebody? Anybody?
4.4 the minus one?
Yes, go ahead.
4.855.
Go ahead, 4.855. Everybody agrees? There will be, just a second. Yeah, 85, very good. Thank you, Sandra, you did very good. And what the next one is? 5.124. And then what?
4 after 2.
Yeah, so that they should add up to 6 here. Can we do it again? Let's just verify it real quick here. Okay. Okay, so it's 4. But thank you, that was very good help. Okay, 4.9. What's that? 3 plus 0.13 what? 43, right? So what we get? 1226. Okay, good.
Why are we adding up to?
Who is talking to me? Brogan? Yeah. Why are we adding? See, this is our estimate, right, Brogan? And this is the give and take part, right? So what we have now is that we are 90% confident that the population mean is no, in this interval, and or plus and minus of this, plus and minus this much of this estimate, right? Am I clear? Now, what was the like a standard measurement for the mean of all the units they come in from? You read it in the description. That was 5 units, right? Wasn't it? Okay, Stephanie, is that clear? We just read it in the problem. All right, then we are just stretching the problem now. Just stretching the question now. Does 5 belong in here? Do you see 5 is contained in this interval? Yeah, interval contains everything, between 4.855, 5.1226, right? In this case, we are ignoring the endpoints, and 5 lives in there, right? Everybody good? Makes sense? Okay. Now, let's just employ the calculator to do it directly, all right? And I think we did it last time. Did we or we did not? If we didn't, we are doing it this time, all right? Okay, here. We want to compute the confidence in a 90% confidence interval, right? Okay, we are just approaching the same solution by a different route. Okay, Sarah? Okay. So here I'm going to stat. Where did I go for that? Somebody? Louder. Say that louder. We can, right? Go to test. Thank you, Francois. Okay. Now, in this case, what do we want? We want the what? We want the Z interval, right? Everybody good? Okay, so let's choose that. And we can get it from the data because we got the raw data here, right? So we'll say, okay, we are going to get it from the data, but for that I have to first enter the data, right? So how do I enter the data? I go to stat, right? Edit, right? Very good. I got to get rid of all these guys, right? So I went upstairs here, said clear, everything is gone, right? So we have 5.32, right? And then, yeah, watch me very carefully, 4.88, 5.1, right? Thank you. 5.15, good, very good. And then the next, but the last one is 4.75, good. So now we have the data, right? So go to stat again, okay, we go to tests, we go to this guy and we say, okay, it's in data, right? Okay, now how much is my sigma? 0.2, right? And then it says, where is your data living in? I say it's in L1. How do I go to the L1? Let me see. Yeah, somebody help, I forgot. Second what? Oh, I see, second one, okay. Now the thing is I messed up everything and I'm recording myself. How embarrassing that is, but that's okay. That's all right. Okay, good. So this is this, and I could not, well, I could pretend I don't have my glasses on, so I couldn't read this L1, but that's okay. No. Okay, L1. And frequency 1 means every number that we have listed occurs once, right? We don't have it like in the form of a table. And what's my confidence level here? 0.90, okay. All right, you guys don't need me, do you? Right? So if we want the confidence interval, and I think it's almost the same here. It's what? For actually, you know what? I think we are the one who made a little typo here. Here, sorry, little computational error here, because when you sub 8, when you take away 4 from 8, that would be 4 anyways. So we almost have the same numbers, okay? Everybody clear? So we got it, and it's good to do it by calculator. We made a subtraction mistake, but it's, and which, you know, the things that do happen, right? Okay, so we discovered it that this should be what? This guy should have been what? So we should have had 4.854, right? Everybody good? Okay, so this is the 90% confidence interval, and we are 90% confident that the population mean that is within this interval, right? Okay, Nurag, am I making sense? Okay. Now, a good question to ask is this: what does a 90% confidence interval mean? Okay. Now, when somebody asks me this question, I mean, I have a lazy answer like, okay, we are 90% confident that the population mean is in this interval, all right? So I said the answer just in terms of the question, didn't I, right? Okay, this means, you know, there are many ways of saying that. One of the ways is this, that this procedure of computing a confidence interval, all right, captures the true mean. How often? 90% of the times. Everybody clear? Okay, that's what a 90% confidence interval does, all right? That is, you know, it might miss it sometimes, but if we followed this procedure, okay, 90% of the intervals contained, you know, created in this manner will have the true population mean. Everybody clear? Okay, let me just show you a demo for this, okay? So here, that how this behaves, all right? So like right now, we talked about having, and this package, you do have it in the computer lab. Remember I told you? Okay. So let's go and get some random data. Okay. And we're just looking at the same kind of a thing. All right. And I know that the total number of intervals that can be generated from a population like this are many, but let's just go ahead and say generate 1,000 intervals, okay? Everybody good? Makes sense? And then I am, so what am I doing first? Just a second. Yes. And I am going to take, excuse me, sample of size how much? Samples of size 6, okay? All right, Helen, everything okay? Yeah, this, okay, good. And this is this, and the standard deviation is what? 0.2, right? Okay, Jack, am I good? Okay, so what we got here? Okay, it's taking a short while, right? So we got what? How many samples? Help. 1,000 samples of what size? Yeah, say that louder, please. Size 6, right? Okay. Just a second. Here we go. Yeah, we have 1,000 samples of size 6 each, okay? So let's bring them over here, okay? All right, and here they are, okay? I'm just going to enlarge them for you, okay? So let's enlarge these guys. All right, and here they're big, and I'm just centering them. Okay, good. Okay. So everybody sees this. Every row has what? How many readings does every row have? 6 of them, right? Okay, Philip, makes sense? Okay. So in this one, let's put the mean of each sample. Okay, makes sense? Okay. So when I'm putting the mean, I'll just go ahead and use this feature here. I want the averages, right? Of who? Of these guys, right? Of these rows, okay? So there we go, and let me enlarge the, what was the size here? Okay, they're saying 5, it's not really 5, it's a little bit over 5, okay? Everybody good? And here we have the means of all the samples, right? Make sense? Okay, now let's write the margin of error, okay? So if I go for the margin of error, okay, I'll just increase this also to 16, and I've tested your patience too much, haven't I, right? Okay, here. So now I'm going to do this, that here I'm going to write down the margin of error for each of them, okay? And you know this, that is, in this case, it will be the same because it doesn't depend on the sample mean, rather than it depends on what? The population standard deviation in this case. Okay, so here you go. The margin of error here is what? All that, right? Everybody clear? Okay. So, and we have the same number here, all right? Okay, and it'll be the same margin of error for all of them. So we can just quickly fill it over here. Okay, does that pretty fast. Okay, good. Makes sense? Okay, now what we are going to do is we are going to construct how many confidence intervals? 1,000 of them, right, Rachel? And the confidence interval has a lower limit, and it has an, excuse me, upper limit, right? How do I get the lower limit? I take this number, right, and subtract who? This right here. I didn't have to write it all. I could have just used that number, but it's okay. I did it, so I did it, all right? Everybody clear? So here are all these guys, right? Everybody good? And here what I have to do, just got to do this plus what? This, and we have all these here, right? Make sense? So does this interval have 5 in it? Does it? Yes or no?
Yeah.
This one? And we don't want to spend the semester just by saying yes or no to thousands intervals, right? Okay, so how about doing
But
this?
the,
Say that again.
there's one which is not have five.
Which one? Oh, very good, Francois. We're so
Yeah, that's one.
This one is a loser, right? Isn't it? Right?
Oh,
Yeah, it
Why is that?
it missed 5. Very good, Francois. We're so proud of you, sir. Very good.
So why is that?
It's just like this. It captures the true mean. How often, Brogan? 90% of the times, right? So sometimes it will. What did I do? I think I am. Okay, let me just do this here. Paste to back. Louder.
I said, so
Mhm.
the error that we just see is about the 10%.
Right. So it will expect it to have 10% of what? Missing rate. Okay. And you can do this. See, what I'm doing is this. Let's sort the data according to the lower limit. Sort. I want to sort it. Okay. Sort by who? Just a second. Sort by lower limit. Let's say smallest to largest. Okay. Now you can see how many of them. Is this a loser? Yes or no? Does that have 5 in it? Yes or no? No, it does not, right? Okay, now you can see none of these guys have 5 in it. Okay, well, everything up to this far has missed 5, narrowly or not narrowly, right? Okay, Marcelo, how many intervals, missed the value of 5? 47 of them, right? Am I clear? Okay, so here 47 of them missed 5, right? Let me just write it here. Okay, and let's see, where is my here? Okay, now let's go down here. Oops, I went too fast, right? Okay, anybody, do you see any losers here? No. You already saw this? No, the other ones. Okay, here I'm going too fast on that. So right here, these, okay, everybody this point on again is losing it, right? Okay, and we have numbers from where? 948 to 1001. So how many on this side? How many? 53. Thank you. All right. So plus 4. Okay, I didn't, this is very interesting. I got exactly 100 out of 1000 missing. It doesn't always happen in simulations, okay? But this happened, and but this happened, so this happened. It's good for our video, right? Isn't it? No? So you saw 900 out of successfully captured the what? True population sorry about that. Makes sense? Okay. So that's that's one way to think about or understand a 90% confidence interval. Okay. So here we are working on this scenario, right? So once again, what we have here is we have a simple random sample of 40 applications, and of course these are from 40 randomly selected members in a large company, okay, and they want to estimate the mean time that it takes to review all such applications, right? Okay, so the sample mean is what? 23.51%. Sigma is estimated to be 6.5 minutes, and we have to construct a 95% confidence interval for the mean, right? So how do we compute the margin of error? We take Z star, and the Z star, that depends on who? The confidence level, right? We multiply it by sigma. We know who sigma is here, right? And we divide it by square root of n, right? So if I wanted my Z star for 95% confidence interval, what would I do? I can go to this, right? Then go to inverse norm. Again, we want a standard normal value, which it has in there as default, so we are not going to put, right. So it is what, approximately 1.96, right? Helen, makes sense? Okay, just 1.96, and if you went to the table, you get the same value. So here we have 1.96 times how much? 6.5, right? And divided by who? That sounds very good. So it's about what? 2.014 minutes, right? Go ahead, Brogan.
I'm sorry, I thought I understood it. I still don't understand why we're not using 95% confidence level.
Why are we using or not? Oh, why are we not using 9? Oh, I got you. All right, so here, let's look at this. Okay, let me just very quickly do this here. All right, here. So see, this is, thank you, Brogan, thank you for asking this. Okay. Okay. This is what we are talking about, right, Brogan? Okay, come on, don't do that. Okay. So we have to find Z star, right? Is that, oops. We have to find who? The Z star, right? Makes sense? And I know this area is how much? 95%, right? Now, I want a value on this scale, which your calculator will give in terms of inverse norm, right? And inverse norm is for percentile, right? And for percentile, what do you need? The area to the left of this value.
Oh, okay, then I understand then.
You understand? Okay, so this is 2.5%, and I know you said I answered it, so why am I going further in there, right? Okay.
No, sorry.
No, don't be sorry. I'm thankful that you answered it. Let's see, let's go, say, for instance, only to 2 digits after the decimal, okay? So what we have here is this then. We got 23.51 minus 2.01, 23.51 plus 2.01, and that is going to be what? Somebody, anybody help? 20, help? Is 21.5. Did I do my arithmetic right?
496.
Say that again.
496.
Oh, I didn't carry those decimals. Okay, I got it, Helen. Yeah, I just didn't go as accurately as you did. But good, thanks for doing it that far. And this one will be 25, 2 actually, right? Very good. Did I mess up? No, it's good. Okay, and of course in minutes. All right, and if you wanted, you can do the same thing using the summary statistics by doing what? Went to stat and then you go to tests, right? And what do you need? A Z interval. Now here, do we have the raw data? Do we? We don't, so that's okay. We got the summary stats, right? So we'll say I have the summary stats, right? Who is my sigma? 6.5, right? Okay. Who is my X bar? 23.51. And who is my N? 40. My confidence level is 95. Okay, very good. All right, I think we have almost the same thing. Yeah, this worked the way Helen did. That is, it worked a lot more precisely. All right, but that's okay. We are close, okay? Everybody fine? Okay, makes sense? Good. So that's the Z interval. We have almost the same thing. Now, let me ask you a question. Okay, how much time do I have left? 5. Oh, yeah, go ahead, Brogan, question.
Okay, that last part where you were subtracting the various,
Okay, so this, right, very good. This is my estimate, right, Brogan?
yeah.
This is margin of error, like it takes 23.5 minutes, give and take 2 minutes, right? Okay, so give and take means what? Here I subtracted the same number, the margin of error, right?
Yep.
Take means, sorry, and
Oh,
the
it's
give
saying,
means.
you're saying plus or minus, okay.
Exactly, plus or minus in a different way. Now, we were going to do sample size, right? How to determine desired sample size, but we'll do it on Wednesday because I hear people pack up.